Hello students, welcome to my class. Today we are going to discuss some more concepts on pulley. Okay, so let us start the class with combination of pulleys. Okay, students, in our earlier classes we have discussed that to lift a load or to shift a load we should use a system of pulley having mechanical advantage at about 2. Okay, but if the load is very heavy, then the mechanical advantage of 2 is also not sufficient. So we need to have mechanical advantage more than 2. So how can we achieve that? We need to have a combination of pulleys so that we can bring the mechanical advantage to more than 2. So that the system of pulley can make our life easy and we can do our work very easily. So we will discuss how we can combine pulleys and how we can achieve the mechanical advantage that has to be more than 2. Okay, the combination of pulley can be done in 2 different ways. The first one is using one fixed pulley and several movable pulleys attached to the same rigid support. Okay, it is to be remembered that the rigid support is same and we have to attach one fixed pulley with several movable pulleys, but all are attached to the same rigid support. And the second one is using several pulleys in 2 blocks, of which lower block is movable and upper block is fixed, known as block and tackle system. So we are going to discuss these 2 ways of combination of pulleys one by one. So we will start with using one fixed pulley and several movable pulleys. Okay, students, as you can see in the diagram, the system of pulleys consists of 4 pulleys A, B, C and D, out of which D is a fixed pulley and A, B, C are movable pulleys. A, B, C are connected with the fixed pulley D, and the movable pulleys, they are connected with separate strings, each having different tension. See, when we compare about the tension between pulley A, B and C, it is clearly seen that the load is attached to pulley A, so it is having more tension than pulley B and C. Okay, so let us find out what should be the mechanical advantage in this case. Students, as you can see in the diagram, effort is put in at the fixed pulley at one side. Okay, so what the effort should be equal to? It should be equal to the tension that is generated by the string which is coming through it. And what is the tension in that? The tension over here is T3. Okay, so the effort is equal to T3. Okay, this is at pulley D, the fixed pulley, isn't it? So let us now find out the relationship between the load and the effort in this combination of pulleys. So as you can see down below where load is attached, there is pulley A. And what is happening over here? It has a tension T1. So what is load? Load is nothing but 2T1. Okay, as discussed in earlier classes, we know that load is 2T1 in case of movable pulley. So what is T1? It is load by 2. Okay, it is suppose equation 1. So let us see what is happening at pulley B. Okay, so pulley B, suppose the tension is T2, that should be equal to T1 by 2, or if we put the value of T1 from equation 1, it is L by 2 whole divided by 2, that is L by 2 into 1 by 2, that is equal to L by 4, or we write it like this for now, 2 square. Okay, L by 2 square. Fine. So suppose this is equation 2. At pulley C then, suppose it is the tension T3 and that is equal to T2 by 2, isn't it? T2 by 2. So what is the value of T2 from equation 2? That is L by 2 square. So that is equal to L by 2 square into 1 by 2, that gives us L by 2 cube. Okay, so this is equation 3. So now we know that T3 is nothing but the effort and L by 2 cube is the value of T3. So if we substitute the value of T3, we find E is equal to L by 2Q. Okay. Now let us find out the mechanical advantage. What do we know about mechanical advantage? Mechanical advantage is nothing but the ratio of load to effort, isn't it? So mechanical advantage is ratio of load to effort. What is effort over here? Let us substitute. So load divided by load by 2 cube, that is load into 2 to the power 3 whole divided by load. Okay. So if we cancel out load, we get 2 to the power 3. That means mechanical advantage is equal to 2 to the power 3. So from here we can generate a formula for mechanical advantage of a system of pulleys where there is a fixed pulley and some movable pulleys. So let us think about the formula. Here mechanical advantage is equal to 2 to the power 3, and you just think about it, how many movable pulleys we have used over here. We have used 3 movable pulleys. That means mechanical advantage is nothing but 2 to the power n. We can write it like this, where n is equal to number of movable pulleys. Okay. So mechanical advantage for a system of pulleys where there is a fixed pulley connected to number of movable pulleys is equal to 2 to the power n, where n is nothing but the number of movable pulleys connected to the fixed pulley. Okay. Hope you understand. Students, as you can see in the diagram, in this system of pulleys, one end of the string which passes through the movable pulley is fixed and the other end moves. That means when the load which is attached to the pulley A, which is at the bottom of the system, it moves a distance, the string at the other side of the pulley which is going towards B moves double the distance. That means if we take the displacement of load as x at pulley A, okay, so the string moves a distance double the distance. Okay, that should be 2x. So what is happening over here? The string that goes through pulley A, it is connected to pulley B. Where is it connected? It is connected to the axle of pulley B. So the string that goes through pulley B and is connected to pulley C has a displacement double the displacement of the axle of pulley B. That means here the displacement is doubled, that is 2 into 2x, where at the string which is connected to pulley C. Okay. So what is it? 2 square x. Okay. Fine. So what is happening over here at pulley C? So again the same thing happens at pulley C. The string that goes through pulley C and is connected to pulley D has a displacement double the value of 2 square x. That is equal to 2 into 2 square x, or that is equal to 2 cube x. Okay. Now where do we put our effort? We put our effort at pulley D, isn't it? So in this case, displacement of effort is equal to 2 cube x. From this discussion, we come to a conclusion that when the displacement of load is x, displacement of effort in such system of pulleys tends to be 2 to the power 3x. So what should be the velocity ratio? That is dE by dl, as we have discussed in our earlier classes. So that is 2 cube x by x, that is again 2 to the power 3. Now again, what is the value of 3 over here? It is nothing but the number of movable pulleys. Okay, so that means we can get a formula for the velocity ratio of a system of pulleys having some movable pulleys and a fixed pulley. That is 2 to the power n. Again, what is n? Number of movable pulleys. Okay. So velocity ratio of a system of pulleys having number of pulleys attached to a fixed pulley is 2 to the power n, where n is the number of movable pulleys. So what is happening with the efficiency then? So efficiency, which is the ratio of mechanical advantage and velocity ratio, has to be 2 to the power n divided by 2 to the power n, that is equal to 1, or you can say 100%. Okay, but practically efficiency of such system of pulleys is less than 100% because it is affected by the weight of the pulleys and the friction that lies between the string and the pulleys. Okay, students, today we have discussed some concepts on pulleys. I hope you have understood everything clearly. If not, please watch the video again. I think you will be able to understand everything. Please read the book and revise again so that the concept will stay in your mind forever. Okay, so keep practicing, keep revising, and most importantly, keep smiling.